This week we're looking at the material from Chapter 2, which has to do with graphs and displays for categorical data and for quantitative data. What we're going to do in this session is look at the difference between what type of graphs for qualitative data or categorical data and the types of graphs that you would want to do for quantitative data. We're going to start by looking at a data set in StatCrunch. You're free to follow along if you'd like to. This data set is called Happiness Data from GSS, and this is a data set that's in our class group on StatCrunch. First in this session, we're going to look at the graphs that we can do for categorical data. So looking at the description of this data set, we have quite a few variables in here that are categorical. The ones that are categorical are the happy variable, health. Income is a categorical variable because it divides income up into different categories. Married, where they answered a 0 for no and a 1 for yes. And religious. The first type of display we're going to look at is a frequency distribution, or in StatCrunch we call it a frequency table. So we're going to start with our first categorical variable, which is happy, and we're going to look at all of these at once. So I'm going to highlight all of those categorical variables. Notice down here that we can do just frequencies, which would just be the numbers of how many are in each category, or we can also have it do relative frequencies, we can have it do percents, or we can have it do a few other things. We're going to use what it automatically gives us, which is frequency and relative frequency. Now when I clicked on compute, since one of our variables is the income had a lot of different categories. It had 25 different categories. So StatCrunch sees that many different answers for the income, and it wants to know if we want it to turn on binning. What that would do is it would take some of those categories we already have and put them all together into one category. So it would group the categories into bigger categories. We don't want to do that because we want to look at each category separately. So I'm going to click cancel for that, and that way it won't do that to us. So here are all of our different frequency tables that it just created for us. So here's one for happy. We had the 3 different possible answers. These are the frequencies that give the numbers of respondents that answered each of the 3 different choices. And here we have the relative frequencies. If we wanted to look at percentages, we could take our relative frequencies and multiply by 100 so that it moves the decimal point over 2 places. For example, the number of people that answered number 2, which was the pretty happy choice, was 110. And the relative frequency of that is 0.58, which means that was about 58% of the respondents that gave that answer. We can see the same thing for the health variable. Looking at the frequencies, we can see how many answered number 3. That was the highest frequency. The lowest frequency was number 1. And over here we can look at the relative frequencies, or we can think about those as percentages. Now here's the one that it was asking us about turning on binning, where it would have put some of our categories together. And we didn't have it do that, so we have all of these different categories. One of the things to notice here is that it doesn't list category 1, and it also skips number 6. What that means is that both of those had a frequency of 0. So nobody in this data set answered for the income category with either a 1 or a 6. That's just something to watch out for if you're doing these frequency tables, because they don't show you the category if there are no individuals that responded that way. And then we have relationship. We can look at the frequencies and the relative frequencies for those answers. And for the variable married, this was a 0 if they're not married and a 1 if they are. you can see looking at these values that these two were very close together. It was close to being half and half as to how many of these were married and how many were not married. And then finally the religious variable. We can see right off that the most popular answer was number 3, which was moderately religious. That had about 42% of the responses were for that choice. This is a good way to look at what's going on with your categorical variables, is to do a frequency distribution or frequency table. The next thing we're going to look at is bar graphs, and in StatCrunch they call them bar plots. So I'm going to graph and bar plot with data because we've got all of the original data in here. And again, it's asking me if I want to turn on binning for the income, and I don't. So I clicked cancel. Here's our bar graph for the happy variable. And this gives us the same information that we got from our frequency table. It just gives it to us in a picture form. And a lot of people find it easier to interpret things if they have a graph, if they have a picture, than if they just have a table with numbers in it. So this shows us right away that there were a lot more respondents that answered with choice 2 than with either choice 3 or choice 1. Here's the bar graph for the health variable. And again, we can see which category had the highest frequency. The other nice thing in StatCrunch is that if you put your cursor over the bar, it will tell you the actual frequency, and it will also tell you what categories that was from. Now, one other thing we can do, if we want StatCrunch to automatically put the frequency above the bar so that we don't have to look it up every time, we can go back to this and check where it says value above bar. When I do that, then it puts the frequencies at the top of the bar for each one. So now we can see what those actual numbers are. Now here's the bar graph for the income variable. Some of these it didn't even put the value above the bar, I guess just because there were too many for it to do. The other thing that's kind of difficult with this graph is that just like in the frequency table where it just skipped the ones that had a frequency of 0, this one just skipped the bars where the frequency was 0. So there's not even a category listed for number 6 or for number 1. That's something you really have to watch out for with these. Here's the one for the relationship variable. Here's the one for the married variable, and this really points out how close together those two were. And here's the one for the religious variable. The thing that I would notice in this one is that this bar is more than twice as high as the other ones, so the frequency is more than twice as much, and these other 3 are almost all exactly the same. The other thing that we could do with our bar graphs, we can ask it to do relative frequencies or percents. So now instead of giving us those numbers of how many people answered with this choice, it's giving us the relative frequency. Now, the other thing that we can do with categorical variables is do a variation of a bar graph, which is called a Pareto chart. A Pareto chart, instead of doing the categories in the order that they showed up in the data, it puts the highest bar as the first one to the left and then goes in descending order after that. So to do this in StatCrunch, we just do a bar plot, but then where it says order by, we ask it to do count descending. This is something we'd use if we really want to point out which category has the most and which category has the least and how they go in between those two. Another thing that we can do with categorical variables is that sometimes we have 2 categorical variables and we want to look at the relationship between them, or we want to take some data and split it up by 2 categorical variables at the same time. So let's do a side-by-side bar plot for 2 of these categorical variables. So the 2 variables I'm going to pick to look at are married and happy. So I'm going to start with married, and so I'm just selecting married for my column, and then I'm going to have it grouped by the variable happy. So what this is going to do is it's going to look at a bar graph for married, but it's going to group it by how they responded to the question about being happy. Here's what that graph would look like. It has two separate parts of the graph for how they answered the married question. So this is all the people that weren't married. This is all the people that were married. And then what we have is relative frequencies. These relative frequencies are overall. So out of all the people in this entire data set, there were 30% of them that were not married and answered that they were pretty happy. If we wanted to know how many of the not married people answered that they were pretty happy, then we'd have to go back and change this a little bit. So here we would want to do either a relative frequency within the category or a percent within the category if we want it to show us that. This time it's telling us out of all the people that answered that they weren't married, 58.8% of them answered with choice number 2 about being pretty happy. So this gives us the percentage just within that category. These are the percentages for these people that were married. So there's two different ways to look at the same thing. Now we could also do this going the other direction. So if we're still trying to compare married and happy, we could start with happy as our column that we're selecting, and then we could group by the married variable. And again, I'm going to have it do the percent within the category. This gives us a different way to look at this same data. This time it's splitting it by how they answered the happy question, and then within each one of those it shows us the comparison between the not married and the married. So this one really points out that the people who answered that they weren't very happy, a lot more of them were not married. The people that answered that they were pretty happy, that was fairly close to being equal between the two, between the not married and the married. And the ones that answered pretty happy, there were about twice as many that were married than that were not married. So these two graphs are slightly different, and they give us slightly different views of what's going on with this data. The next kind of graphs we're going to look at are pie charts. And pie charts, for the most part, are only appropriate for categorical data. So I'm going to create pie charts for all of our categorical variables. And for these, you can have it display the count, which would be the frequency, or the percent of the total. And this one, it automatically does both if you don't tell it anything different. So here's our pie chart for happy. Pie charts can be useful partly because people are used to pie charts. They're not too hard to understand or interpret. For the happy variable, we can see easily that number 2 had a lot more responses than the other two choices. Here's our pie chart for the health variable. Here's one that's not especially useful for the income variable because there were so many different classes. We have all these ones over here that are just tiny little slices of the pie. This graph doesn't really tell us a whole lot. We could see if we tried that number 20 has the highest frequency, it has the biggest slice of the pie, but beyond that, this really isn't giving us a whole lot of information. So this would be one where this graph isn't especially useful. Here's the one for relationship. We can easily see that the marrieds are pretty close to being half of this data set. Here's the not married and the married, and here's the religious variable. Another thing we can do with pie charts is we can look at two different categorical variables at once. So we can do a group by with this also. So for this one, let's do relationship. And let's look at that, how that's related to the happy variable. So I'm going to group by happy. Now what this does is it gives us 3 different pie charts. So one for each different response to happy. So this was the ones that said they were not very happy. We can see a lot of those are never married. This one was the pretty happy response. So almost half of those are married. The smallest of these is the separated. And then with the pretty happy, we can see a big percentage of these are married. The next biggest is the ones that were never married. So this is kind of an interesting way to break down the responses to these two different questions. To summarize what we just talked about, for our categorical or qualitative data, these are the types of graphs and displays that are appropriate for that type of data. So we can do frequency distributions or frequency tables, bar graphs. In StatCrunch, those are called bar plots, Pareto charts where the bars are in order from highest to lowest, side-by-side bar graphs. These are useful if we have two categorical variables or if we want to break down one categorical variable by using another one also, and pie charts. Now we're going to look at our quantitative variables and some of the graphs and displays we could do for those. And for this, we're just looking at graphs and frequency distributions. Next week, when we talk about Chapter 3, we'll look at some other types of values that we can get for quantitative variables. First, we're going to start out with this with frequency distributions or frequency tables. These are a little bit different for the categorical variables than they are for the quantitative variables. So our three quantitative variables in this set are age, children, and education. And I'm going to leave this so it does the frequency and the relative frequency. Now this is another one where we have lots of different values for the ages since the people were just giving their age. So it asks if we want to turn on binning. I'm going to do it first where we don't turn on the binning so you can see what happens. If you don't ask it to turn on binning, then it's going to give you one for each different age that was listed in the data set. This is a lot of different numbers, and this is really not telling us anything at all. There's so many different values in here that this really isn't helpful. So really what we would want to do is go back, do this again, and when it asks us if we want to turn on binning, we're going to say OK this time. What that does is it has StatCrunch create some categories for us. If we were doing this frequency distribution by hand, we'd have to create our own categories. But StatCrunch did it for us. The bad thing about doing this in StatCrunch is we don't have any control over how it does these categories. There's no way to change it. The other problem with doing this in StatCrunch is that technically for a frequency distribution for a quantitative variable, the classes or the categories can't overlap. And if you look at how it lists these classes, it looks like they're overlapping. For example, this one goes from 10 to 20, this one goes from 20 to 30. Now actually they're not, because in StatCrunch what this is actually doing is it's starting at 10 and going up to the last number before 20. So this is actually going from 10 to 19, this is going from 20 to 29, and 30 to 39, and so on. But you wouldn't know that by looking at this. So this is kind of confusing. You have to really make sure that you understand that if you're going to use StatCrunch to do frequency tables. This does give us a good idea of what's happening with our data though. So for the ages, we can see that we had more people in the 50 to 59 age group than anything else. You can look at the actual frequency or the relative frequency. The one with the least number was the 10 to 19 age group. That only had not even 2%. And we can also see that a lot of our data is kind of in the middle here between 30 and 70. There weren't as many on either end, but there were a lot in the middle of that. The next one is the children variable. And this one just had a few discrete values because this was something that answered the question, how many? How many children do you have? So this one, there were only 8 different answers that people gave for this. We can see again that we had 2 that happened more frequently than the others. The 0 children had 50 responses and the 2 children had 56 responses. And then as we got towards the higher end of this, we had fewer and fewer responses. And then last, for our education variable, this is another one where you have to be careful looking at this frequency table, because notice it skips all the values from 1 through 5. It goes from 0 up to 6. That means that for 1 through 5, there were 0 people that answered the question that way. Next, let's look at histograms. And here's where I get picky in our class, the difference between a bar plot and a histogram. A bar plot is something that's used for categorical variables. A histogram is something that's used for quantitative variables. And there are some differences between bar plots and histograms that make it more important to use them for the right type of data. So let's do histograms for our 3 quantitative variables. Now we can compare the histogram to what we got in our frequency table. A lot of times we'll create a frequency table and then we can use that to create a histogram. In this case though, if we look at our histogram, we can see that the classes here are actually different than what they gave us in the frequency table. These ones, the classes have width 5 because, say, this one starts at 20 and goes up to actually 24. The next one starts at 25. The next one starts at 30. So these are all width 5, where these classes were width 10. So this is giving us a slightly different result and a different picture of the data than our frequency table over here did. If we want our histogram to match the classes that are in our frequency table, we could go back to this and edit it. So we want our bin width to be 10. And now we have a histogram that matches what we have in our frequency table. This is more useful to a lot of people because they find it easier to look at the picture and tell some things about the data than they do by looking at a bunch of numbers in a table. So from this we can see the highest frequency class is the one from 50 to 59. The lowest is the one from 10 to 19. And we've got most of our data grouped in this area. So especially between age 30 and age 59. That's where a lot of our data is in this histogram. Now the reason that I'm picky about the difference between histograms and bar plots, let's look at a bar plot for the age variable, and we're going to tell it to, yes, go ahead and do the binning. So this is really the same graph, but notice the difference between these two. The histogram, there are no gaps between the bars, so we can see this is a continuum of the ages. In this one, it really separates these bars so that we've got big gaps between each of these bars. The other problem with this is if you have a lot of classes, since it puts the classes down here, sometimes this gets really hard to read. We again have this issue like we did in the frequency table where it looks like the classes overlap, because this one goes 10 to 20 and this one goes 20 to 30. So really for a quantitative variable, you should be doing a histogram instead of a bar plot. The bar plot just doesn't give you as much control over how to do the classes, and it doesn't tell us as much because there are those gaps between the bars. Now let's look at the histogram for the children variable. When we look at this, this looks like a bar plot. We have all these gaps between the bars. This is just a weird thing that StatCrunch did with this one. If we look at the classes for these, it actually made the class widths 0.5. That doesn't make any sense because that would be saying that we had a half of a child. So what we would want to do with this one to make it look right is go back and tell it that we want our class width to be 1. That fixed the problem. So now we still have 1 bar for each response in the children variable, but the bars don't have any gaps between them. And this one corresponds exactly to what we had in our frequency table. So we can see we had a couple of high frequency classes over here. And this goes down as we go from left to right. We have more of the data on the left side and a longer tail on the right side. As far as the distribution shape, this would tell us that it's skewed to the right. The direction of the skew is the direction that the longer tail is. So since this has a longer tail on the right, more data on the left, that makes it skewed to the right. The other one we can look at is the education histogram. And for this one, we have a class width of 1. So this actually shows us all the different responses to the years of education. Now the nice thing about doing a histogram for this one is that it actually shows us where these classes were that had 0 responses. So it actually shows us that there's a gap between the 0 and the 6. That's something that it was a little bit hard to see in the frequency table, and if we did a bar graph for this, the bar graph would not show us that gap. We'd have to notice that for ourselves. So again, for this one, a bar graph is really not a good choice. It would be much better to do the histogram for this one. Now for this one, if we wanted to group these differently, we could go back and change the class width. So for this, for example, if we wanted to make the width 4, that would make fewer classes that we'd have to look at. This gives us a little bit different picture of our data. This tells us that most of our data was in the 12 to 15 years of education. So that would be people that finished high school and possibly had 1, 2, or 3 years of college. Then the next highest one is from 16 up to 19. So again, this is people who had from 4 up to 7 years of college after high school. We can see that these other 3 classes had very few respondents. So there were only 3 in the 0 to 3 class, there were only 4 in the 4 to 7 class, and there were 3 in the 20 to 23 class. This histogram does something that our frequency table over here didn't do because, again, StatCrunch won't let you decide on your own bins or your own classes for this. So this one we didn't have any way to group those together. This one gives us a little bit nicer picture of what's happening with that data. One more thing that I want to show you, sometimes you have quantitative data that you want to split up by different categories for another variable. So sometimes you have a quantitative variable and a categorical variable that you want to look at the same time. Let's say that we're trying to look at the ages of these respondents, how that connected to how they answered the happy question. So one way we could do this is to do a histogram. A histogram is for a quantitative variable, so we'd want to select age as our column, and then we could group our histogram by the happy variable. It's going to give us 3 different histograms because the happy variable had 3 different possible responses. So this is going to divide our respondents up into how they answered that question, and then it's going to do a histogram for the age for each different one of those. So here are our respondents that answered that they weren't very happy. So there were a lot more of these in the younger age group. This went down as our respondents got older. So the older the age of the respondent, the less and less of them there were that answered that they weren't very happy. For the pretty happy response, this one has a lot different shape. There are a lot more of them in the kind of middle ages, less on the 2 ends. And for the very happy response, again, this one has a few more on the younger ages and less in the older ages. Now, if you're doing this in StatCrunch, if you want to have these 3 graphs side by side, then really you just have to do the 3 separate. So you have to do this 3 times in a row. So I'm doing this 3 times with exactly the same thing. so that I can look at the three different graphs all at once. So here's our not very happy, here's our pretty happy, and here's our very happy. And we can see the differences in what those look like. This is something that you can use if you have a categorical variable that you can use just to split this into 2 or maybe 3 different sets of data. Now let's look at another type of graph we can do only for quantitative data, and that's a stem and leaf plot. So let's just do a stem and leaf plot for the age variable. What this does is it takes the values in the data and splits them up. It makes one of the digits a stem, and then the digit to the right of that is the leaf unit. So in this, it's saying the leaf unit is 1. So in other words, the 9s right here are the 9 and 19. This would be a leaf of 9 and a stem of 1. So that means they have a 1 in the tens place and 9s in the 1 place. The nice thing about a stem and leaf plot is that it actually gives us what all the data is. This tells us that there were 3 people in this data set of age 19. We could look at the oldest person in this data set would be this last one here, and they would be 84. We can also use this to look at the distribution shape. The highest frequency would be the 50 to 59 class because it goes over the furthest to the right. So we can look at whether the distribution is skewed or whether it's symmetric and bell-shaped and that kind of thing. Another type of graph for quantitative data is a dot plot. Now, this one doesn't work for all quantitative data because this uses each individual value in the graph. So this one works well for something like the children variable where you only have a few different responses. For children, we only had 8 different responses. We had some discrete values. So the dot plot for this is going to come out pretty well. And what this is doing is it's doing 1 dot here for every respondent that answered that they had 2 children. This looks a little bit like a bar graph because we have just these different bars for each of our different values. Now if we tried to do a dot plot for the age variable, this is one that isn't going to work very well because we have so many different answers for the age. This graph really doesn't tell us very much. The only thing that we can really see from this graph is that over here at the 70 plus ages, there aren't as many respondents as there were in the younger ages. But really, it's not telling us anything more than that. Now, another type of graph we can use for quantitative variables is a scatter plot, and this is for 2 quantitative variables. So if you're using scatter plots, you have to make sure that both of your variables are quantitative. Neither one of them can be categorical. And we'll look at an example here and see that scatter plots don't always work even for 2 quantitative variables very well. So let's look at the age variable and the children variable. And what we would be looking for here would be a relationship, if there is a relationship between the age and the number of children. What this is going to do is plot a point for each different row in our data. So for example, this first row, we're going to have a point plotted on the scatter plot that has 66 for the x value and 4 for the y value. So that's what all these points represent. You can put your cursor on a specific point and it'll tell you the row it came from and the x value and the y value. But this graph, this isn't really telling us anything about the relationship between the 2 variables. So this is a place where we had 2 quantitative variables, but the scatter plot really isn't very useful. And we could try education and children. Those were also 2 quantitative variables. But this really isn't showing us anything very good either. Well, let's look at a different data set. We're going to look at the one called Marriage Age 1950 to 2003. This data set gives us the average age of first marriage for men and women from the year 1950 to the year 2003. So what we could do with this, we could look at the relationship between the year and the average age of first marriage for men, or the year and the average age for women, or we could look at the relationship between the men's and the women's average ages. So let's start with the year as our X and women as our Y variable. So this would look at the relationship between the year and the average age of first marriage for women. So this does show us a pattern. This is someplace where a scatter plot's useful. We can see that as the years went on, so as our X variable increased, so did our Y variable. As the years went on, the average age of first marriage for women was increasing. This doesn't exactly look like a straight line. It looks like there's more of a curve pattern to it, but at least we can tell that it's increasing from left to right. Now let's look at the relationship between the men's age and the women's ages. This one does look like it has a straight line trend. So for this one, we could say that there's a positive linear relationship between the two. And in fact, we could even say there's a strong positive linear relationship because this does look like it's so close to being in a straight line. This is a relationship that a scatter plot is very helpful for. For one final thing, we're going to go back to our happiness data set. And we're going to look at pie charts for quantitative data. Everybody wants to do pie charts, so we're going to look at one place where it works out pretty well and one place where it doesn't. So one place where the pie chart might work well is with our children variable, because that, remember, just had a few discrete values. We only had 8 different values for the children. So this one, the pie chart actually might be helpful. So we're just going to try and create that graph. So yeah, we can see some things in this pie chart. We can see right away that number 2 is the biggest. The 0 answer is pretty big, and we have some ones over here that didn't get very many answers. So this is actually not a bad graph for this particular variable. For the most part, for quantitative variables, I'm not going to want you to do pie charts. So let's look at a pie chart for another one of our quantitative variables and see what's wrong with it. Let's look at the education one. Now this is one where this isn't especially helpful. We can see that number 12 has the most responses, but we've got all these little slices over here. We can't even see what they are from the graph, and this really isn't giving us very much information. In your assignments in this class, if you're doing pie charts for quantitative data for the most part, I'm probably going to ask you to go back and find a different type of graph, because most of the time these aren't going to be very helpful. So overall, for our quantitative data, here are the types of graphs and displays that we can do. So we can do frequency distributions or frequency tables, histograms, not bar graphs, but histograms for quantitative data, stem and leaf plots, dot plots for specific types of quantitative variables, and scatter plots. If you have 2 quantitative variables, with the ones that we looked at, some scatter plots are going to be helpful and some of them really aren't. Here are different ones for categorical data. Here are different graphs for quantitative data. The only one really that's the same is that we can do frequency distributions for either one of these 2. Other than that, this is why it matters whether the data is categorical or quantitative, because we are doing very different types of graphs for the 2 things.